Hey guys, this is the question that I posted on LinkedIn. So, have a look at the below two Verilog quotes. So, it is like in the first always block, you are having B is equal to A, C equal to B, and Q equal to C. In the second always block, I have changed the order. So, how will it affect? So, before watching this video, you need to have a clear understanding about how blocking assignment and non-blocking assignments will work. I have made a video on it, you can go back and watch anytime. So a short thing is, this blocking assignments will execute parallelly. These are non-blocking assignments, they will execute parallelly. This blocking assignments will execute sequentially. Sequentially in the sense one by one. So yeah, let's see this. In the first always block, one more thing, whenever we need a storage, we will get a flop here. So whenever there is a requirement of storage, you will be getting a flop. Remember this. So let us say we got a positive edge in the clock. At the same timestamp here itself, all the statements will get executed and a synthesized digital block will be given. So first statement is like B is equal to A. Second statement is C equal to B. Third statement is Q is equal to C. So if you observe here, at the same timestamp, first the value of A is getting transferred to B. You remember, right? Blocking means it executes step by step. So whenever you are getting into the second step, the value of B which is calculated in the first step, that will be given to C. So indirectly C is getting the value of A, correct? And if we see the third step, here Q is getting the value of C. So indirectly at this time instance, Q is getting the value of A. So this always block is equivalent to Q is equal to A. These three statements and these statements both are similar. So you will be getting only one flop. So it is like output will be Q, input will be A. Output is Q, input is A. And this is clock. This is a D flip-flop. Output is Q. So let me keep this aside. Okay. Next, if you see that this always block, the second one, the statements are like Q is equal to C, C is equal to B, and B is equal to A. So at the same timestamp, all the statements will start executing one by one. So if you observe the first statement, it is Q is equal to C. So it is like Q is getting the value of C. And in the second statement, B is equal to C. So it is like C is getting the value of B. C is getting the value of B. But if you observe here, the value of B is not calculated in the first statement. But in this always block, the value of B is calculated in the first statement. That's why this statement is redundant. But here value of P is not calculated. That is the reason we will be getting another flop here. And if you see the third statement, B is equal to A. Even the value of A is also not calculated in the first two statements. So you will also be getting a third flop. So this is the flow. If I draw the circuit, it is like Q is equal to C. So let's start from bottom. B is equal to A. So output is P, input is A. And this is like C is equal to B. Output is C, input is P. And this is like Q is equal to C. So input is C, output is Q. And these are all D flip-flops. You will be having a clock. Correct? This is the circuit for second always block. For the first always block, it is simple. Output is Q, input is A. Clock, D flip-flop. So just try to understand what is happening. And if you have any questions, please post it in the comment section or ping me on LinkedIn. Yeah, that's it guys. See you with next question. Bye bye.